Testing, testing, 1, 2, 3, testing, testing. Okay. Morning, everybody. How's everybody doing this morning? Well, I hope. Let's see here. Where were we? Oh yeah, we'd finished this one. That's cool. That's cool. I'm clipping. Yep. Bring that down a little bit. Hello, 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 hello. Testing, testing. Testing! Test, test. Okay. Yeah, the mic, I don't know, it was clipping a little bit. I'm using the built-in on my laptop again. How am I? Oh my goodness. Well, first of all, not sure why there's so few viewers this morning, but, you know. I was told that this microphone is better than the one that's attached to my headset, but if you want me to switch back, then if I get 3 requests in the chat to switch back to my regular microphone, which is this one right here, then I shall do so. Yeah, holy smoke. Yesterday there was a huge power outage in my area, which is, it affected Hamilton, the lower city, and it affected all the way to St. Catharines, so I understand. It was caused by a strong windstorm. Oh, a calc test? Yeah, that'll do it. Switch back. Okay. Alright. Hello. Let me test that now. Muskoka. Wow, jeez. Yeah. Better? Hello, hello. Yeah, that is better. That's weird. Alright. Who knows why. Scott, you are lucky that you only had the power out for a few minutes. We, in my location, we had it out from about 2:30 in the afternoon all the way till midnight, so, you know, we now have a bunch of fridge stuff that might be questionable. Fortunately, the freezer seems to have weathered the storm, but Brantford here had the power flicker a few times, but no outages over here that I know of. Well, count yourself lucky. I was actually in the middle of doing work and stuff, and, like, the power went out, and now, you know, I'm maybe a little more behind on my, work for this week than I usually use Sunday to try to get a jump start on the week, but, you know, it is what it is. My wife and I were playing Monopoly by candlelight. My mic is a little bit muted, eh? Maybe I can pull it up a little bit now that I have Hello, 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 hello. Try to stay out of the red zone. Doot, 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 doot. I think that's as much as I can give it without it clipping, so if that's not loud enough for you, I guess, I don't know, you could turn it up on whatever device you're listening to it on. I could also move the microphone a little closer to my face. That usually has the same effect. Anyway, we should probably talk about our lecture material for today, eh, guys? Enough of this idle chit-chat about power being out and such. So anyway, we're done talking about classes. So now we're going to talk about files. So file handling is a subject that's usually covered in these types of programming courses because there's only so much that you can do usefully with a closed-off little program that only has available to it the inputs that you can provide via command line or interactively. Normally, once a file starts working with enough data, it becomes very, very useful to learn how a program might interact with the actual files on your computer. So we're moving now from a view of computing that only sees the RAM, and we are now moving into being able to interact with the ROM, your hard drive, your file structure, your files themselves. So let's take a look. We're going to talk about files, the internet, file formats, CSV, JSON, and XML files. So, there may be some options on, yeah, I can use that directory. There are some options on print that you may not have been aware of. I'm going to go over this stuff very quickly because you guys, presumably you guys already know how to use print and input. But there are some optional parameters on print that may be interesting to you. For example, separation. If you specify sep is equal to new line rather than the space that it usually is, you can say stuff like hello world, and those will appear on different lines. The default for separation is just a space. So there you go. You can also change what the terminating string is. So by default, it's a new line, which means that each time you enter something, it ends up on a new line, like it automatically puts the new line in so that the prompt ends up on the next line. However, if we make that into a big fat nothing, you can see that the new line character isn't actually appended to the end of the string, so the terminal itself is. So, you know, so there are some options on print that you may not have been aware of. So why are we talking about these basic things? It's because it turns out that you've been doing file I/O this entire time. When you use print and input, you are interacting with system.standardout and system.standardin, which are standard input and standard output. And even, we can even go further and say, when you generate an exception in Python, what happens is that you are interacting with another system file called system.standarderror, STDERR, which, between the three of them, they handle a large number of the operating system's sort of, well, there's a reason they're called standard input and standard output. It's a lot more evident when you're in a Bash or Linux type environment, because standard input and standard output are right there for you to see in a command line interface, but they are always there, even in Windows. So we can interact with general files in a manner that's reasonably similar to the way in which we interact with standard input and standard output. In command line scripts, we can redirect standard input and output to files, which is outside the scope of this course, but, oh, yeah, you don't have to worry about it. Let me see if I have any comments or questions. Had an outage this morning, too, across half the globe. Really? Wow. Am I really that quiet? Let me just see here. Okay, so let's talk about files. So if you want to work with files, there's a basic procedure for it. We work with what are called file streams and file handles. So when you open up a file, you read from that file kind of like you would be reading with from standard input using the input function. The only difference is, rather than prompting the user for input so that something ends up in standard input, which is, what the user has put there, all of the things that you're reading already exist. They're already in the file. Talking about the case where you're reading stuff in this case. So when you open up a file for reading, you create what is called a file handle. A file handle in Python is an object which contains all of the information that's required in order to keep track of your position in the file and where the file is in your operating system and all of the stuff that's related to that. All of the stuff that you don't need to know. So, this is good. And when you're writing to a file, it's a very similar procedure. Rather than having all of the things that you want to read already in the file, presumably you would have all of the stuff. You either already have all of the data somewhere in some data structure inside of your program, or you're generating it on the fly. At any point, the important part about all of this is that there is a specific procedure. You first open the file and create the file handle. You then perform whatever actions that you need to on that file handle. And then, when you're finished, you have to close the file handle. You have to close the file. So, there's a very good reason why you have to close files that you open. When you open up a file, the operating system, if it's a decent operating system, is keeping track of what files are open and by what program. And so, when you have a file open, the operating system prevents other programs from accessing that file. It assures that you have exclusive privilege to that file for the duration of you having that file open. Now, the reason that you would want exclusive privilege to file access is a reasonably complicated thing, but essentially it boils down to, if you have a file open and another program opens it and makes changes to that file while you have that file open, it could result in inconsistent behavior. So that would create what are called race conditions, where what the resulting output of some number of file the output of, the both of these programs taken in consideration together would depend upon which one of those programs is given given the CPU first, essentially, right? Whichever of those programs is given the CPU first, that program will make the first changes. So that program that goes first, it changes the file, and the other program, if it's reading the file, it can see those changes, and therefore its output will be different. It's sort of in the reverse case if you're worried about things writing at the same time. Whichever program writes to the file last, those are the changes that actually end up taking place, and the other changes get overwritten. So it's just a big mess. You don't want files being accessed from more than one program at a time. So the operating system manages all of that. However, in order for the operating system to manage all of that, you, the programmer, are expected to close files when you're finished with them. When you close a file, it releases control of that file back to the operating system, so that another program can then open up that file and modify it. You can actually reproduce these types of things if you, for example, in Windows, I believe if you open up an image file, if you try to modify that with more than one image program at once, you'll probably get a pop-up from your operating system saying, or not the operating system, but from the second program that you try to open the file with, that says this file is already in use. So it's very important to close files when you have opened them. Of course, one way to close all of the files that are on your system is to restart your operating system. But anyway, so this is how you would do that in Python. fh.open myfile.txt, this is just the file name of the file that you want to open. R specifies read mode. We can assign a string to fh.read, filehandle.read. Read is the method that gathers the input from the file. And then, of course, we want to close the file handle. We can then print what the file contained. So let's try this out. Let's do that. In the other class, I'm doing some assembly programming with them. So let's make a new file. File stuff.py. Make a new thing, and let's file handle is equal to open. Let's open hello.asm. We shall open that in read mode. String is equal to filehandle.read, and then we close it. Because we've already stored the information that we need in the string s, we don't need to have the file open anymore. The file contained there we go. And then Python 3 file stuff.py. And there we go. That's the contents of the file. This is an assembly program. This is what Hello World looks like in x86 assembly code. Anyway, but assembly is not important. Don't worry about assembly. Incidentally, you can get the same effect if you just use the Linux command cat. It stands for catalog. There you go. So, Okay. Hey. Oh, we got some more people. Did I get a haircut? I did get a haircut. I got a rather severe haircut, actually. My hair is very short now. But, you know, it was one of these find the largest setting on a pair of industrial strength, sheep shearers and have at thee. It was very epic. So this is so we have a few more, pardon me, sorry guys, I didn't get much sleep last night. So we've got our open function, which opens file name and returns the file object file handle. Mode specifies the mode. R is for reading, W is for writing, and A is for appending. Appending is, of course, adding lines to the end of a file. fh.read reads the entire file into memory and returns it as a string. And fh.readLine reads the next line into memory and returns it as a string. The string includes the new line character. Blah, blah, blah. If the end of the file is reached, the empty string is returned. fh.close closes the file and frees the resources associated with the file object. So, let me just demonstrate readLine to you. So rather than reading the whole thing, we could say s is equal to an array, and we could say for while let's say q is equal to fh.readLine, while q is not equal to the empty string, s is equal to s appending q, and then q is equal to fh.readLine. There we go. And the result of that will be slightly different. You can see the result of this guy is that instead of getting one string that contains everything, we now have each line in this file as a separate element in the list that we have constructed. This would be exactly the same idea as if you read the whole, just did a regular fh.read and then split on new line characters. Except I think that would delete the new line characters. But anyway. So, Python has a way of avoiding having to manually close file handles. If rather than writing, if you use the with construct rather than sort of using manual assignment and invocation, you can basically Python, it's one of the Python constructs that assumes that you're doing a certain thing with it. So just like with for loops or I don't know where I was going with that. Sometimes Python assumes you mean to use the code in a certain way, and this is one of those times. If we go with open hello.asm in read mode as file handle, this creates the file handle variable using a with clause. With clauses are something we haven't actually discussed yet, but it's essentially the file handle object is only scoped to everything inside of the with clause. So it's a way of scoping a variable without having to use a function invocation. So when you do that, you no longer need the file handle.close. Python is intelligent enough to understand that this is a file handle, and that when you go outside of the scope of the file handle, you'll want to close that file handle, and it does so automatically. So this is the exact same code, but we don't need manual file handle closing. I'll see if you guys have any questions. Cat. Cat. You guys, I don't know, is there a cat around here? I don't think there's a cat. We need cat. I don't know. Maybe there's a cat. I'm not going to interrupt the lecture, though, to go grab the cat. So this is reading line by line, which is a thing we already did. Lines will include the end of line character, new line. It can be removed using the rstrip method. Okay. So, yeah. And here's another interesting thing. Where you can also replace this while loop with a for loop. So when you're looping over a file handle, in the same way that Python kind of just knows when you're for looping over a dictionary that you want to do every entry in the dictionary, when you for loop over a file handle, Python knows that you want to do every line in the file. So line here is implicit. It can make implicit the read line invocation right here. So all of that, so this code is equivalent to the following. For q in file handle. There you go. Same difference. So this is Python making things easier for you, requiring fewer lines of code. Category. Meh, yeah. Maybe after we're done. Cool. We can also use exception handling to prevent us from reading files that don't exist. So, for example, if we had a file that didn't exist, what would happen when we try to run that is that we get a file not found error, a file not found error exception. We can try catch that. Or try except. In other languages, it's called a try catch. Print, you're dumb. Boop, 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 boop. There we go. Name S is not defined. Oh, yes. That only makes sense in the context in which this worked. You're dumb. There you go. So, now let's move on to how to write stuff, now that we've learned how you might read stuff. We'll just do it down here, I guess. With open new file.txt in write mode, fh.write roses are red. If we run this, we get an error. FH is not defined. Oh, as FH. There we go. So, although no output is produced, we can see that a file called newfile.txt has been created, and that if we take a look inside that file, it says roses are red, but notice it has no new line character. If you want the new line character in there, you have to put it in there manually. Run, and then take a look. There we go. If you want to write multiple lines into a file, you can use multiple invocations of fh.write. Violets are violet. Whoever said they were blue anyways? There you go. So you can just, and like you can easily imagine how you might write stuff using a loop, right? If you put the fh.write invocation inside of a loop, then you could write everything in a data structure into a file reasonably easily. Let me check to see if you guys have any questions. If we don't have read access to a file, if we get a file not found error or other errors like permission denied error, that's a good question. That's a good question. So let me answer Hansen's question first. I think it's in slides 9. There we go. Code. If I set the properties, if I set the permissions on this, and let's say we make new file.text read only. Or yeah, let's restrict those permissions. Cool. We get a permission error rather than a file not found error. So there you go. That's your answer. That's your answer there, Hansen. That's a permission error rather than a file not found error if the file has not the permissions to be able to be modified in the manner in which you're trying to modify it. I'm just going to set those back. Ba-boom. If there is already text in a file, does the write function overwrite it? Yes. So let me demonstrate that for you. Let's open up new file.text and say buts. There we go. If we execute our thing and we take a look at what it contains, you can see that it has been overwritten. And in fact, it says the file has changed on the disk, you reload it, and there it goes. So that is a textbook case of a file being overwritten. If there is no file, will it create the file under that name? Yes. If there is no file, and you're opening a file in write mode, it will create that file, for sure. If you want to add to the end of a file rather than overwriting the file, then rather than opening it in write mode, you would open it in A, which is append mode. In that case, when you execute the function, you can see that it's adding it to the end of the file rather than overwriting what is already there. So there you go. Answers to questions. So incidentally, so we already know what open does, we already know what write does. You can also use print for this, interestingly enough. If you're like, man, write just doesn't have enough options for me. I am a mover and a shaker who demands more options from my writing functions than write is providing me. Then you can also use print for this. If you specify file is equal to file handle, then print can also print to a file rather than just to standard output. This is kind of cool because you get the separator and end options, and it implicitly it implicitly converts everything to a string, whereas filehandle.write, whatever is here must explicitly be converted to a string if it's not already a string. So there you go. So let's so yep, if we try this again, we can say print something that's not a string, like 1, 2, 3, 4, or even better, 1, 2, 3, 4, file is equal to file handle, and there you go. So the interesting thing about string conversion is that the string conversion is the same one that's used to print stuff in the Python interpreter. So if you're viewing what a data structure looks like in the Python interpreter, that is actually exactly what it'll look like in the file, because it's the same string conversion that's occurring in both cases. So there you go. If the file does not exist, does the A mode create the file as well? That's a good question. I don't know. Let's try it. A and new file 2. It creates a new one. There you go. It creates a new one. So, you can also just write to system to standard output directly without having to worry about all of that. If you import system.standardoutput.write a bunch of stuff. See, it writes a bunch of stuff. And of course, because this isn't print, we need to append the new line character manually. There you go. So, any questions about that before we move right along? If not, we're going to talk about reading data from the internet. So, reading data from the internet is very, very similar to reading data from a file, except the file handle is a file handle for a remote resource rather than a local file. This makes it a little bit more complicated because stuff that's out on the internet might be encoded differently from the stuff that's locally encoded on your computer. But obviously, there are ways of getting around this. We will use the URL lib module to open remote resources. So, if we import url.lib.request, we'll see if this file still exists on this server. Yes, we will. Let's just do that. Yeah. So, we import url.lib.request. We have a URL, which is a website address. Our response is url.lib.request.open URL, URL open, and then we give it the URL we want to open. And s is equal to response.read. So let's see what we get as a response. Oh, I need to save that before we try it. So, we get a 404 error. This website, so this does not exist. This is not a thing that has been found on the internet, which means that probably the slides need to be updated. Yeah, document not found. However, if we go to home, maybe we can we can take this is the professor that put together these slides, by the way. Maybe we can just access that. There we go. Print S. So we didn't get a 404 error this time. And instead we get what looks like the actual contents of this web page in HTML, which is cool. You can view that kind of stuff if you right-click and view page source. So if we take a look at this, this seems like it would be exactly the same thing. Doc type HTML, HTML lang equals English, and yeah, that is precisely. I've only checked 2 of the lines, but this appears to be the thing that was read from. So there you go. You can access web pages. Now, you know, interpreting the web page as something that can be read from, that's sort of a job that's best left to a web browser. But you know, you can read data from the internet. And of course, a file that's stored on the internet does not have to necessarily be in the form of an HTML page. You know, something that we would interpret as a website file. It could be a text file, it could be a CSV file, it could be literally anything. So there you go. Data read from a URL is a sequence of bytes. It could be binary data, or it could represent a string. If it represents a string, special characters, such as accents and emoji, could be encoded in one of many different character formats. So, we've kind of gotten lucky here, because the encoding that's being used on the web page is the same encoding that we are using in our bash feed here. However, this is not necessarily the case, especially if you're trying to open a web page from a different part of the world, right? Like if you're opening a web page from Japan, or if you're trying to open a web page from India or something like that, it's entirely possible that they're going to be using a different character set from the character set that I would be using in North America, for instance. So, it turns out that you can actually get the character set from, you can ask the website itself what character set it's using. So, we can assign to our, so the response itself is a object that contains a lot of data, right? Not just the actual contents of the web page. So, we can get response.info.getContentCharSet. That will tell us what the character set is of the website that we are reading from. So, let me just put that in there, and we'll see what we get. None. Fair enough. So, sometimes a website will specify what character set it's using, and sometimes it won't. It has to be somewhere in the document, right? If it doesn't, we can add the phrase or ASCII so that if this comes out as null, we will by default use ASCII encoding. You guys remember ASCII encoding from like the second week of slides, right? Hope so. But anyway, ASCII is just like, it's the most basic one that most people use, so it's like a good default. At any rate, we can set a char set variable equal to this response, and we can decode our response according to the character set that's being used. Decode char set. Then when we print it, it kind of already worked because it's already encoded according to the default, but not ordinal and range. Oh, that's interesting. So ASCII doesn't work here. How about UTF-8? Or UTF-16? How about that? How do you like them apples? Well, it seems like the best thing to do would be to just leave it as default then. Jeez. What if the URL goes to a photo? Well, then you would, in this particular case, you would, well, actually, I can demonstrate that. Let's take this and go to page. It would be view image. Yeah, there we go. So that's actually the URL of the image that's being put into the web page. So if we take a look, change that to this, there we go. Don't worry about that character set nonsense. Pardon me. You basically get the image, but in raw data format. So this is what the raw data format for an image looks like. If you want, you could you could write this to a file, and then that would be a way for you to, using a Python program, copy an image file from the internet to your local system. So there you go. Thank you. Cool. You can, of course, read things line by line if you wish to, using the same for loop construction that you would use for the file handle. In this case, the response object is very much like the file handle object. So for line in response, s is equal to line.decode character set, if you're worrying about decoding character sets, of course. And you can handle errors, as we demonstrated previously. If you try to access a file that doesn't actually exist, then you get a URL lib.error.http error. So, if you get a HTTP error, then could not load resource. You know, exception handling as you understand exception handling. I'm not sure why this needed its own section. Jeez. So, files have formats. This should not come as a surprise. Everything has a format. PDFs have a format. Python scripts themselves have a format. We're going to talk about some file formats that are commonly used for transferring data between programs. Probably up to this point in time, most of the files that you've been working with have been designed for specific programs. You know, .doc goes for Microsoft Word, .pdf is being read by a PDF reader, you know, etc., etc., etc. But there's a sort of a handful of file formats that are commonly used for data transfer between programs of wildly different types. So, you know, if you have Microsoft Excel, they take .xls files. If you have OpenOffice's Calc, then they have their own file format. But both of these spreadsheet applications will read a .csv file. CSV file stands for comma separated value. JSONs are a way of encoding lists and dictionaries in a file, and it stands for JavaScript object notation. XML is extensible markup language, and it does sort of several things as well. There are many more, but these are the three that we're going to focus on. And if you're wondering about what the testable material is, that's usually either CSV files or JSON files. XML is a little bit complicated and kind of not as... it's a little more subject to interpretation, shall we say. So because CSVs and JSONs are more strictly and rigidly defined, they make better test questions. Normally you can expect to see either one or two of these on the exam. One year, actually, I did convert a CSV file to a JSON file and then back again, and that was an exam question. Anyway, I'll take any questions that you have. If you guys give me some questions, I'll see if I can grab one of the cats. Be right back. Almost. Hello. Question, is this the Events PDF reader? Hello. Oh, kisses. Yeah, this is Events. It's, I don't know, I really hate Adobe, because it's, like, constantly needing to update, and it has such an Adobe is, Acrobat Reader is so impressed with itself, it's ridiculous. Like, sometimes you just need something to read a PDF, you know? And Events is like it's a good optimization point between, like, lightweight and having features. There's another PDF reader called MooPDF, which I think I might have on this machine, which is, like, even lighter. Stands for micro, right? The Greek letter for micro. Topic 9, there we go. File not found. Oh, yeah, that would be because the file doesn't exist. There we go. And this is MooPDF, which, as you can see, is very simple. Doesn't even have, like, bars or things. It is just the thing that it says on the box. But, you know, it is nice to be able to print a PDF, so MooPDF is not good for everything, but it is extremely light on system resources. Have I ever used Windows before? If yes, when did I switch to Linux? That's a good question. Yes, I've used Windows. I have used Windows quite a lot in my lifetime. I started off using Windows 3.1 on a compact Presario, but I eventually made the switch to I eventually made the switch to Linux. I didn't switch entirely, though. The system that I'm currently doing this streaming on is a dual boot system between Windows and Linux. There's some stuff that's better, like some of my thesis stuff is, like, can only be done on Linux, and, you know, some of the other things that I like to do, like, most of the Steam games, that's all on Windows, so I find myself straddling the gap. But I switched to Linux in my undergraduate years. When I got a new laptop, I decided to dual boot it between the two operating systems, which is I highly recommend that as an exercise to, get into programming and, like, a different conception of what a computer is. What is assembly programming? Well, it's a long story. But assembly programming is essential, like the essential the essentials are that your CPU has an instruction set. So there are a set of commands that your CPU executes. Normally there's a huge layer of, normally you're kept very far away from sort of the raw bare metal programming that goes on inside the CPU by such things as compilers and high-level languages and levels of abstraction, etc., etc. Assembly programming is programming directly in the instructions of the CPU itself. So if you take a look at that file that we were using as an example, these are CPU instructions. So this is moving a literal value into a register. This is moving a literal value into a register. This is, I think, moving the address of this message into this register. We're moving this into this register, and it's a lot of memory manipulation. It's a lot of register manipulation. You've got add. So this program here computes 14 plus 10 and then prints it. It's actually importing printf, which is a C function. But yeah, it's programming in the machine instructions of the CPU itself. If you're in the computer science stream, then you'll probably see it at some point later on, probably in third year. But generally speaking, the only reason that you would need to program in assembly code is if you are looking for extremely fine optimization. Compilers are very good, but we're still in a situation where hand-optimized assembly code can beat compiled code efficiencies. But yeah, I don't know. Check the syllabus, or check your course calendar. There's probably something in there. I've wanted to try Linux, but I'm afraid I might break my laptop. Will you do a setup video? I'd like to see the gear. Well, I mean, it's really not much for the streaming. I'm just using OBS for the actual streaming part. My laptop, I'm using my laptop's dedicated webcam. I'm using this pair of headphones, and my lighting is coming from this desk lamp. So it's really kind of I haven't spent a lot of money on it, let's say. I've been adapting things to. Yeah. But with respect to installing Linux, so I'll run you. I realize some of you, you guys have class to get to, but I'll run you through the basic procedure. Number one, you never want to install Linux on a system that already has stuff on it, unless you have done a complete backup of everything that's on your Windows computer. Generally speaking, I'll only install a new operating system on a brand new laptop because I'm very I'm very cautious about that sort of thing. So the way that it works is, the first thing that you have to do is you have to partition your hard drive. So if you're not aware of this, your hard drive has a number of partitions on it. One of those partitions will be the boot sector, which is not something that you guys should ever mess with unless you really know what you're doing. That's where your computer boots its operating systems from. That's actually why, when you look at the advertised storage capacity of your hard drive, your sort of Windows partition will never be quite as large as it. You'll always be a few gigabytes off or a few megabytes off. So you want to partition your hard drive. The danger is, I'll explain this for the benefit of the rest of the class then. the danger of installing Linux on a thing that already has stuff on it is that you have to take a section of your Windows partition and you say, okay, you take a great big meat cleaver and you go shunk. That's a Linux partition now, and it gets completely, like anything that's in there gets completely destroyed. So if Windows has any data inside of the partition that you're making into the Linux partition, that data is now gone. It is destroyed. So if it's not backed up, then you lose it permanently. That's why I, generally speaking, only install Linux on systems that have absolutely no data that I care about on them. So, generally speaking, the other thing to keep in mind is that you won't need as much storage space on your Linux partition as your Windows partition, just because things in Linux don't take up as much space. Do you recommend separating the home directory from the root directory? I mean, it depends. I don't go for particularly nerdy setups. Like, as Linux setups go, mine is very, very vanilla, very baseline. I probably shouldn't say this to the internet, but, it's not like I'm encrypting my home directory or anything. Don't worry, though. By the time within 24 hours, my home directory will be encrypted because, one shouldn't admit to such things on the internet. But, yeah, I don't know. My general feeling with Linux is that you can do a lot of things that don't necessarily accrue to you much benefit, but are a lot of work to set up. Separating root from home just seems like one of those things to me. Yeah. You can if you want, though. But yeah, I run Ubuntu, so I have a friend of mine once said that if you're not installing Ubuntu, then you're just a hipster. Ubuntu has pretty much anything that you would need as a Linux distribution. Sometimes I've run Debian. I doubt anybody here knows how to hack into a Linux directory. Yeah, it's not so much that as, the fact that I'm making these lectures publicly available. But anyway, I can always just chop the end of the video off, but that's fine. Yeah. Yeah. If you want a real challenge, you could install something like Arch Linux or Gentoo. But anyway, you guys, I'm gonna sign off here. Take her easy, folks. I'll be talking to you tomorrow. We'll talk about more nerdy stuff. Take her easy.